Hello students. Now that we've learned about dilations, let's dig a little bit deeper into scale factor. We used scale factor in order to figure out how to draw the dilation in the last video. And this one we're going to figure out how to find the scale factor if we are given information. So the scale factor is the ratio used to dilate a figure. And remember, scale factor is represented by the letter K. You remember that from the last video. Now to calculate scale factor, depending on what numbers we're given, to calculate scale factor, K equals new over old. So whatever the new number is, or the new length is, over the old number or the old length. That is the way we find scale factor. Okay? If K is greater than 1, the dilation will be, do you remember what that is? Yeah, it's an enlargement. And if K is between 0 and 1, the dilation will be you remember what that is? Reduction. And some people might call it a shrink. But you should know both, okay? So now let's figure out how we actually determine the scale factor when we're given the information that we're given. So let me get my paper up here. Good. Okay. So let's say we're given an algebraic representation. If my algebraic representation says xy arrow 2.5x comma 2.5y, then I can just look at that and tell that my scale factor is 2.5. Because remember, we always multiply the scale factor times the x and the y, so that would make my scale factor 2.5. Is that a shrink or an enlargement? Yep, you're right, it's an enlargement. Okay, so now let's say I'm given a description. If point L, which is 3, 2, is dilated and becomes L prime 4.5, 3, then the scale factor K equals what? So this is where I use K equals new over old. And the good thing is I just have to pick one number, either the x's or the y's. Now I know that L prime is going to be the new because it's the prime. Prime is always the dilated figure, that's the new figure. So that means L 3, 2 must be the old. So I'm going to take, I don't like using those decimals, so I'm not going to. So I'm going to use the y's. I'm going to take the new y, which equals 3, and I'm going to put it over the old y, which is 2. So that means my scale factor is 3 over 2. Now, do I need to change that to a decimal? No. Is it okay to do that? Sure, but you don't need to waste your time. It's okay to leave it as 3 over 2. Now, if your answer choice is, say, 1.5, then you would need to do 3 divided by 2. But leaving it as a fraction or an improper fraction is just fine. Okay? So once again, we took the new y and put it over the old y. Now, the cool thing is, if we chose the other one, we could also do 4.5 over 3. And when you divided that in the calculator, you also get 3 over 2. So you could use the x's or the y's, it doesn't matter. So my K equals 3 over 2. Okay? And now we have a graph. So there's a couple of different ways that I can do the graph. Okay? Now it's very important that you listen closely on this. One of the things I can do is I can look at the lengths of sides. Now, I can only use horizontal lengths or vertical lengths. I can't use the slanted lengths because I don't know exactly what size that is right here. But if I took the lengths, and I'm going to do this, I'm going to do two different ways. So we're going to do this by the lengths. If I look at the original figure, now how do I know which one's original? Because it's just STUV. Okay, so the original figure, the length ST is 1, 2, 3, 4, 5, 6 units long, so I'm going to put a 6 right there. S prime T prime is only 3 units long. So I'm going to take the I'm going to take the new length and put it over the old length, and that's going to be the new length, because it's S prime T prime, is 3, and the old length is 6. So that means that my scale factor is 1/2. Now, does that make sense? Well, yeah, I went from a very large to a small. So I know it was going to be a fraction because it's a shrink or a reduction. Now the other thing we can do is pick 2 points. So I want to pick point v prime, which is 1, 2, and we're going to choose v, which is 2, 1. Is that right? No. I was wrong because I wasn't paying attention to the scale over here. So v is actually 1, 0.5. That's v prime. V is then 2, 1. Okay, so I have my new and my old. Actually, I just have new over old. So I can choose k equals new over old. And once again, I don't really want to use those fractions. So I'm just going to use the x value. So the new x is 1. The old x is 2. So that gives me my scale factor as 1/2. So again, well, I guess it would be helpful if you could actually see all that, wouldn't it? Sorry about that. So again, what I did was I can choose either the length of the side if I use a horizontal or vertical length only. No slants. Or I can find the ordered pair for one of the points, and then I can do new over old for either the x or the y to find my scale factor. So we're going to be practicing lots of different ways to find scale factor because we need to know how to find scale factor, but also how to use scale factor.